the cameras are being used mostly for reaction. But the hard part was real-time video artificial intelligence. No one really knew about ChatGPT. A lot of issues that we initially faced were around evangelization.
When you're trying to affect change, the hardest thing is how does that fit in to a cohesive, larger vision?
Your ideology.
For those kind of things, you need to reduce your thresholds.
And what are some of the other bets that you've taken early?
It has to be edge AI. Second being bandwidth, because you cannot push this data to the cloud due to multiple reasons.
Time to talk about now with M1.
The entire M1 chip
no Mac has ever done before.
the world's fastest CPU core.
And as soon as the M chip launched in 2020, we took a bet on it. Apple might be our best bet for video AI.
Better start testing this thing now. Turbocharging the hype is Anthropic's latest model called Mythos.
Model is not the product. Model is just the intelligence layer on top of the product. I feel robotics is the future.
At SRI, we are experimenting with a mobile robot.
I'll be back.
Focus on training your engineers. Get your hands dirty first.
Most founders building with AI right now are selling a version of the story where everything is faster, cheaper, and better. Shivang is the only one I've heard tell the other half. The half where application layer of his engineering organization collapsed overnight, where working with agents cost him real mental bandwidth, and where the thing VCs told him not to do is the thing now he thinks is the only way to survive in the next 5 years. If you're leading an engineering team and you're tired of hot takes from people who have never shaped AI at scale, this is the conversation.
Hey Shivang, welcome to the pod. You have been working on vision for a while now, even before it was cool or hyped up. Can you walk us through the journey and why did you take a bet on vision? First of all, why did you want to work on vision, and how did the journey start?
So the journey with vision started around 7 years ago. And before that, I was a founding member of another company which got acquired, and I was there in the it was a fintech company, and I was there for 1.5 years. And in the meantime, one of my founders, like the previous founder, the company which got acquired, he was looking at a lot of conferences around security, and he was looking at like millions of dollars spent on camera infrastructure, which I think every enterprise has at this point of time. The thing that he noticed was the cameras are being used mostly for reaction. Something happens, then you go into video management systems, scrub through the videos, and then find the evidences. Then he pitched me an idea about, let's make this camera infrastructure reactive, not reactive, but proactive. Can we utilize this camera infrastructure for different kind of use cases, not just security for that matter? And he pitched this idea, and I was like, okay. I mean, this is my second company as co-founder, so I was sold for that idea. But again, it was 2019, and no one really knew about ChatGPT at that point of time, or GPT for that matter. But the main CV detection models, they were there since 2016, but not that great. But we took a bet like it'll be mainstream probably in 3 to 4 years. COVID actually delayed that a bit for us, but we had an idea like main CV will become mainstream in 3 to 4 years. And that's why we took a bet on video artificial intelligence. But the hard part was real-time video artificial intelligence, because I mean, from CCTV cameras, if you want to do something proactive, you need to do it in real time. And doing that was the hard part, and not the computer vision part. The detection models were getting better and better over a period of time. The YOLO model, which is there. So when we started in 2019, YOLO was already on its third version. So detection models were already there, Generative models are recently coming in, like VLM models that we talk about. But computer vision overall, it was early then. But the hard part was mostly real-time video artificial intelligence than actual CV. In the end, systems engineering doesn't change. So a lot of video streaming platforms were already there. So you can imagine real-time inference requires video streaming first, and then you add a layer of model inference on top of it. A lot of issues that we initially faced were around evangelization because AI was new, computer vision was new. No one real, I mean, before 2019 or before computer vision altogether, people were using products which used to give answers in yes, no, right? If this is true, this is false, these
So
kind of
machine learning paradigm essentially.
right. So, but with machine learning or artificial intelligence products, it is more, I mean, you just get some signals, right? It's probabilistic in nature. So thinking about solutions in probabilistic nature was something that we had to evangelize our customers initially. For example, we have a product called fire and smoke detection. In fire and smoke detection, you don't want to miss any kind of smoke and fire because it's catastrophic in the end for end customers. But for those kind of things, you need to reduce your thresholds, which means you'll have false positives. Now, in the end, customers want to, it can be frustrating as well. Like, why are you giving me false positives? So it's a journey of more evangelization, which was a problem for us. Like, AI in itself is probabilistic, and building products around that, which users were not comfortable with initially. ChatGPT actually was a great boon for us because people started using ChatGPT or AI in their daily use cases. And that helped a lot for us to get the traction, to get adoption in the market and all of that. So initially people were thinking about, oh, are you doing a science project instead of actually building product? But over a period of time, after first 2-3 years, people actually started thinking about AI as products, enterprise products for that matter. So it started maturing overall in the market.
Interesting. And what are some of the other bets that you've taken early that you still have high conviction on, be it from a technology standpoint or specific approaches?
The first bet that we took was it has to be edge AI. Because I mean, we are dealing with CCTV cameras and real-time inferencing on top of it. So if you look at a small warehouse or a small retailer, they have somewhere between 20 to 40 cameras. And if you want to do real-time inference on that, that means that 20 cameras in HD giving you like 240 frames per second on which you have to do inference. That's a lot of data. You cannot push this data to the cloud due to multiple reasons. One being privacy. People don't want to push their camera feed to cloud. Second being bandwidth. I mean, imagine 20 HD cameras, that's like 200 gigs of data every hour. Like, and in remote places and edge places, you don't have that kind of bandwidth available. So it has to be edge. So we initially took a bet on Apple hardware as well. Like Apple hardware can produce this kind of throughput for us. And as soon as the M chip launched in 2020, we took a bet on it. There was a reason around it because if you look at all the video editing softwares, they are built for Mac hardwares, right? So we thought that video AI might be, Apple might be our best bet for video AI. So that's why we took that bet. And I still believe like that's our best direction that we took initially.
That's pretty unconventional. Apple is essentially a consumer hardware, and you going to them and with a commercial use case, or even thinking about them as your sort of commercial partner for the entire company inference, essentially. How did you think about that?
There were multiple reasons for that. So one, we wanted a commodity hardware because I mean, our thesis was computer vision at some point of time will become commoditized. And for that, you need a commodity hardware that you can buy from any shop and you can place anywhere. So how it has helped us is we are there in all the continents except for Antarctica and Arctic. So, I mean, other than that, every continent we have this, and not because of, and just because of the Apple's supply chain that's already there, right? So we don't have to worry about the supply chain. We don't have to worry about the hardware piece. We just worry about the software layer on top of the hardware piece, right? So that was a big bet for us. It was the initial first 6 months when we started thinking about building on Apple, because everything was built around CUDA, right? All the libraries which are there are built around NVIDIA. And that was our main challenge, like how to port all of this to Apple's hardware. So we had amazing engineers, uh, research engineers as well, who actually did the initial bit of that, and that has really paid off after that. So that was the, I mean, initial 6 months we were like, oh, is it the right choice? But I mean, as a founder, sometimes you have that conviction, like this might be a good choice. Let's stick for it for a year and then figure out if it doesn't make sense. So it paid off for us. One thing people don't realize is Apple does a lot of open source projects, and the CUDA's kind of libraries, Apple has already provided the interfaces for that. So we work one layer above that to make sure that the model are compatible and are and we are able to use that on Apple. But yeah, it was a lot of work initially to make sure that the models can run seamlessly on Apple hardware, and obviously building. I mean, everything has been built around Linux systems. So a lot of software engineering work was also required on-prem, because you want to build a hardware. In the end, you are a hardware edge product, right? So you want to build a product where updates are easy. You should be able to remotely manage that. So the first few pieces that we had written was automatic updates, remote management. We should be able to SSH into the boxes, and all of these kind of things, which is the orchestration layer on top of the actual software. So I think if you are a good architect and engineer, that's the path that you'll follow. And it was all systems engineering, by the way, not really like AI ML related work, the first few iterations that we did. I still feel like the end game is edge AI, and Apple probably will be very in a very good space because of that. They are focusing a lot on the edge AI space, so inference, as you mentioned. So I think that will be the main focus from Apple, because they haven't really, they are not spending a lot of money building cloud infrastructure for that matter. So I think edge AI is their focus. I mean, I'm not sure about Apple. Like they don't reveal a lot of stuff, but I think that that's where this is going. Detection models have been there, and they are pretty good at doing their stuff. What I feel is detection models, the generative model, the VLM models that we are talking about, they are not yet there for real-time video artificial intelligence. It will probably take 2 years, 1 to 2 years, so that they can do at this pace, right? So you need, like, for example, 200 frames per second. Can it do it? Not at this point of time. So at this point of time, how I think about vision models is like how humans actually evolve, right? So if you ask me a question about engineering, I'll be able to probably answer that. But I'll probably be able to give you some generic answers about some other topics like law, etc. But if I need more depth answers around law, I'll probably go to one of my friend who is a lawyer, right? So imagine similar kind of stuff for models. So there is a generic model which is running on-prem, which is giving you some signals, and then there is a specialized model around your distributed cluster, which you can push the data to get some more answers if required. So vision model is going into that direction, where they are composable models, where you have some specialized models, some generic models, and users can plug and play these models to get some jobs to be done for them. So so as a company, we focus on jobs to be done. Like in the end, you are solving a customer problem for an employee who wants to do some job. So job can be as simple as so for example, we work with airports and and theme parks. And in theme parks, you would have seen wait times for each ride. So that comes from us. So there are cameras present at the line where people create queues, and so this is something that used to be done by someone sitting there, like, oh, right now it will take 15 minutes, then it will take 20 minutes, and all of these kind of things. Now it can be done by vision. Now this is a very specific problem, but in the end, it's some algorithm on top of the vision data that you got, the detections, the number of people that were there in that area, right? So right now the detection models are doing great, and you can combine it with some specialized models to actually solve some vision problem statements for end customers. But it is my hypothesis that more and more specialized models or more and more generic models will become smaller and smaller in size. And I believe in 5 years, we'll see robotics as the main game where everything is happening on a $100 edge compute, and it is able to make decisions pretty quickly. So I feel the journey is evolving from LLMs because of a lot of structured data on the internet. Then it has gone to vision, and it will probably go to spatial next, which is robotics, in 5 years. So I mean, this can be a controversial take, but I feel single product companies won't survive long. And as a company, you have to be like multiple products. So we at Dragonfruit are sort of a venture studio where we have multiple business units because we figured it out early that computer vision overall, I mean, we built the platform first for real-time computer vision, right? So, and it has different use cases in different verticals. So from the start, we were thinking about it as a venture studio sort of a company where you have multiple business units, and each business unit is being handled by a GM who is managing the P&L, product, and everything. But the product team resides at the base platform layer so that we can abstract whatever we can across BUs and create it at the base layer versus something specific which can be built at the BU layer, right? So I think companies will start building a lot of application platforms now, so that building applications is easy for them instead of like writing back-end code, front-end code specifically for each use case. So a lot of abstraction and generalization will be required there. We as a company were always thinking about it as multiple use case company. So we started as the platform first, and then building an app layer on top of it, so that individual GMs can decide like, oh, this is the kind of the depth I want to go into this product suite, so that they can quickly build the application on top of the base platform. So initially it was a lot of traditional sort of a software engineering company, right? So it was platform engineering was there, infrastructure there, then it used to be front-end engineering was there, then application layer or the back-end layer was there. So it was a lot of traditional sort of a setup initially. But with AI, I mean, this has changed drastically. What we are now thinking about and implementing is there is a base platform team which takes care of the base infrastructure, the end-to-end platform, the video flowing from the cameras to our system, like that is working well. That includes infrastructure. Then we have different pods for each BU, business unit. So they take care of the depth of the product, like what exactly we need to build for that business unit. Now, there's a thin layer in between of these two, which is the application platform layer. So because the business unit teams actually just interact with the layer, which is also abstracted out from the platform, so that they can quickly build applications for their business units. So it has evolved a lot, and these pods are not like large teams. This is like one engineer who can actually handle the full business unit. So DevOps is still there. We are looking at infrastructure monitoring tools and all of these kind of things, but But DevOps, the base layer is still intact. That hasn't changed, but the application layer has changed a lot. So platform engineering has also not changed a lot. The iterations are faster because you are not writing a lot of code, but the thinking process of systems engineering and all of that hasn't changed for us. So good architects, system engineering, DevOps is still present. Those teams are still there, but application layer has totally collapsed. Application teams are now involved in other aspects of the company, like GTM engineering. Like, can we build websites internally now instead of using, let's say, Wix or some other tools at this point of time? So a lot of, I feel, good engineers will be sought after more because they'll be required in every department of your company, not just engineering going forward. So that's the structure that we have at this point of time. One thing people don't realize is the infrastructure code or the platform related code also, as the models are getting better and better, they are able to figure out the patterns better, right? So 1 year from now, 1 year before, I wouldn't say that I will give architecture related stuff on the platform side to, let's say, Claude. But at this point of time, I'm like, you should first discuss with Claude and then come up with the plan and then implement it. So the whole thesis around implementation has changed a lot. So infrastructure and platform team also, they have a mandate to first come up with a plan using Claude or other agents and then implement that. They shouldn't be, they should be basically talking to them, discussing with them to come up with a plan, to come up with the different approaches that can be taken, and then do the implementation. Obviously, there is a small part in between where we have a discussion internally to make sure that it is relevant for us, performant for us, etc. Like the traditional stuff that we used to do. But with the application layer code, we are not much bothered about, because at this point of time, you can just have, let's say, 15-minute agent. Agent can produce the same code again or better it. So we focus on release it. If it doesn't work, junk it, rewrite the code, and then release it. But on the platform side, we are a little apprehensive about that. So we have a step in between where we go through all the security related stuff, benchmarks that we have, and then try and release the software for the platform related stuff. Not a lot of engineers understand that this API call might be done by like millions of times in a day. So if you'll not give that kind of context to the model, then it will not actually build the right output. It will not tell you like, oh, you need to put indexes on these columns for that, right? So those kind of issues we saw initially, and we thought that it's time to build the knowledge base around it, which is a company-wide knowledge base, which should give you the base architecture about like, oh, this is how the product looks like, this is the scale that we are looking at, and that gives the right context to the model and provide a better output than what it used to be before. On the contrary side, like the amazing stuff that we saw about AI, we are new in like every business unit is a different kind of vertical that we go into. Now, at this point of time, you can actually tell the models or Claude like, oh, like these are the competitors in this business unit. Can you come up with the product ideas around that and actually start building those products? So before this era, you need to hire a lot of people to figure out the depth of that business unit. But now it is getting easier and easier for leaders to actually go into different kind of market, build something, try it out, see different competitors, how they are building, and based off that, figure out the product for yourself. So, and it has given us like multiple of these kind of products for each of these business units. And with the pace in the last 6 months, these like churn out pretty quickly. You can test out pretty quickly. Have the full GTM engine built internally so that you can test out a new product, let's say, in 2 months instead of a year, which it used to take before. So it has accelerated the pace a lot for like GTM for these kind of business units that we have. So the idea is you have so much of wisdom available. Wisdom is commoditized at this point of time, right? So you have a product manager in your agent. So just work with them to come up with the right product spec. So this is more about exploring ideas. I mean, humans look for ideas, like evolve those ideas into structured outputs, and that's what we want from engineers also to do. I mean, they have some vague ask that has come up. Can they discuss it with a product manager in an agent and come up with the right structured output that they can build from the vague input? And I think that has helped us a lot in making sure that the engineers are motivated, they understand end-to-end systems, because that's also really, really important, because you want to integrate into your existing system. So the context layer that we were talking about, if that is clear, then the team can focus on more ideas, more exploratory stuff that they want to do. A lot of new ideas actually come from engineering these days, because, oh, this is the new business unit. This is a specific idea that I saw some competitor also doing. Should we build it? And they'll come up with the MVP these days to actually show to us, rather than we asking them to actually do it.
Going back to the vision piece for a bit, how do you think the vision is going to evolve with generative models? There are a lot of things happening right now. There are world models being built, and there are VLMs which are getting smaller, maybe in the short term for a bit larger, but then maybe smaller. And you did speak about general purpose VLMs or generative models as a alternative to specialized architecture that you have. Then in that case, do you think that you have a threat from these companies or generalized models, or do you think differently?
My perspective is what vision was 6 years ago is robotics at this point of time. So robotics is at a stage where a lot of companies are gathering a lot of data. Tesla, for example, has a lot of data because, I mean, they have been in the market for quite some time. And a lot of companies are at this point of time just gathering that data, because LLMs were the start, vision is the second, and spatial intelligence is the third one, which will come up in the next few years. I feel in the next 5 years, robotics will be commoditized. At this point of time, it's a little specialized field, but with edge compute going like plummeting, I feel we'll have robots, like, let's say, running on $100 to $200 boxes on-prem with models. So I see that future in 4 to 5 years from now. So again, LLMs to vision to spatial, and that's the journey that I'm seeing building in vision for the past 6 years. We are a little in a very interesting space, because in the end, most of the video data that gets generated is via CCTV, right? So CCTV data kind of becomes your nervous system, where you are gathering a lot of data. Frankly, we haven't really explored like how it'll impact the VLMs. But yeah, security guardrails, I mean, those will be really, really important. I'm not sure if everyone knows about Light LLM, that the security vulnerability that came in. I mean, these kind of things will start happening more and more, because no one is really looking at the code. They are just pushing things out. So yes, a guardrail around model building, behavioral model building, like guardrails around that will become really, really important. At this point of time, everyone who are using open source models, they are not really focusing on this, because everyone thinks that open source models are would be fine. They are generally trained on a lot of open source data, but there are biases in open source data. So for example, what we try to do is to look at like sample data, the detections that we are doing. We look at some of those sample data over a period of time to see how the model is behaving. And a lot of this is done automatically. We have a team also who looks at this data to make sure that we are not going away from the core performance of the model, because we train a lot, because we get data from so many cameras, like tens of thousands of cameras every day. So we have a lot of data coming in, and we train these models every day, fine tune these models every day. So we have some benchmarks, like, oh, these are the kind of things that should be detected this way. And if they don't follow that pattern, I mean, we go back and look at the data again to see, make sure that the behavior is right. So that layer needs to be there. And every company that is building any vision related stuff should have this kind of layer on top of their models, model building or training. At this point of time, I feel it'll be, I mean, both of them will coexist, because in the end, we as humans also have some specialized humans who are doing some specific jobs. Same kind of mental model is there for these models which are coming in. So there'll be some generic models where some generic robotic models where you are okay with some false positives, some things going haywire. But some of the use cases you might want to have like 100%, like, oh, this is how it should be done. And for them, you'll have specialized models. So they will coexist, like models are coexisting right now. ChatGPT is, for example, a generic model, but then you have coding specialized models. Similarly, I feel it'll be in the case of vision and robotic models that will come in.
Yeah.
Core things that I'll say to all the engineers, all the engineering leaders, is focus on training your engineers. Get your hands dirty first to understand the power of this new paradigm that where we are, and then inculcating that to the engineering team that you have. And this will take a top-down push, not like, it will not happen like suddenly one day. It will need a top-down push from you guys to actually make them understand the nuances and other stuff, and spend time, spend money on this, because this is the future. But at the same time, be a little, I mean, as humans, we need to understand the complications, the other things that other humans are also facing. So there are both the aspects of this. So focus on training, focus on making sure that people understand what they are doing. Try and do it yourself. Then only you'll kind of understand that. Figure out problem statements, figure out the way of imposing problem statements to engineering so that they are excited about solving those problem statements, rather than just distributing tasks to them. Because as humans, as engineers, we sort challenges, and if challenge is not coding, then it has to move somewhere up at a meta level, which is more product problem statements, rather than like coding a very complex algorithm for that matter at this point of time.
Yeah. So essentially, you move up the stack and help your team do the same, right?
Yeah.
Cool. And finally, where can folks find you, and what do you have any ask for the audience?
Folks can find me on LinkedIn. I am co-founder and VP at Dragonfruit AI. So they can look up on LinkedIn and just connect with me.
Awesome. Thanks a lot, Shivang, for spending the time. So much of real insights and wisdom. Yeah, thanks for that.
Thank you so much.